Good. So we're recording. So I'm going to share the screen again. So this is the vector. Okay. So what I do first, you find the norm, which is the length of this vector, this squared plus this squared, all in the square root.
Sorry for bothering. May I ask a question?
Yeah, sure. Go for it.
Where will this video will be uploaded?
I will upload or send it to your email in Google Drive or something. So.
Okay. Thank you.
You're welcome. So you find the length of this vector, which is the root of 29. I think everybody agrees with that. And what I denote this by the lowercase small a hat, which is the unit vector for this guy. That should be ax I hat plus ay I y hat and az k hat, right? So I took this vector, divided by the length, and you get this guy here. You do the mathematical massaging here, you just do the calculate this with the calculator. You get 0.37 I minus 0.93k. That should be the unit vector. Okay. This is along vector A. This is the unit. Don't forget. So yeah, there is where I have written it. So I have said that dividing the vector with its norm length give the unit vector, right? So the next question.
Something about this.
Sure, go for it.
In the exam, when I entered the result in like I and K, it says like the answer does not depend on I or K or something like that.
You're right.
I think we were meant to give it as just 0.37 without the I or K in the exam.
Oh, okay.
This is the worst part of online exams, because
yes, because it's like it took one of my attempts, like giving the result like that.
You can express this guy like in this fancy way. Maybe computer will not accept it, even though you are right, and you get 0 for that. That is so insane. That's why I don't like the remote examinations. That doesn't make any sense. But anyway, in these hard conditions we are experiencing, going through, that's manageable. So we get now the second question says, there's a vector, find the vector, let's say B, which is perpendicular to A. Perpendicular means that this vector times this vector, inner product, is called inner product, right? Is the length of A times the length of B, the cosine alpha. This is alpha, but since it is perpendicular, this alpha should be 90 degrees. Eventually, this vanishes, right? What does it mean to vanish? So we already know the vector A and now the vector B. When you're multiplying these two vectors, you should multiply this component by this, plus ay plus this, plus az plus this. All right, so that is what I did here. And you get 2b1 minus 5b3. This should be 0. On the other hand, I got this relation. There are infinite vectors perpendicular to A. Okay. For simplicity, does it say 2 vectors or so?
Yeah, it says construct 2 unit vectors that are perpendicular.
Whoa, where are we? Just okay, it doesn't matter. So just find 2 vectors. You can take any vector in this form. So this vector here is going to be perpendicular to A. So for any value of B, can take a value like in real numbers. So you can get infinite ways. I took one for fun, just to try. Like let's say B3 equals 2, and this B eventually 2 and 2 goes, and 2 remains here is 5i minus 2k. So this is the vector which is perpendicular to A. Is that like, does it make sense? Do you understand what I'm explaining?
Yep.
All right, sounds good. So, and the part C says, find the unit vector which is anti-parallel to A. Okay, so what does it mean? If you find A, which is unit vector parallel to A, if you put a minus sign, you get in the opposite direction, right? So if you, let's say minus A is minus 0.37 plus 0.93k. And this is the answer for question number 1. So I think that was clear. Let's say problem number 2, which is like where I have some disagreements with what's being explained here. Why are so many of those? All right, let's go to problem number 2. Is it problem number 1? 4.
Sorry, during the PS also we will solve the midterm questions, or
No, I have
we will
some
solve.
other beautiful questions.
Okay.
I'm just going a bit quickly, and I'm going a bit slowly so that you can understand what's going on here. So we have, suppose you're inside a rocket on the ground at initial time 0. Start from the 0, right? The rocket is fired from the ground with a constant upward acceleration of 7 meters per second squared. Suppose you shut the engine off after 11 seconds and step off the rocket. Assume that the rocket is in free fall after this engine is shut off, and ignore the effects of the air resistance. So what happens here? So there is a fancy guy going to the, like, boarding the aircraft or a rocket, and then the rocket goes up. And after 11 seconds of going up, the engine stops. But when it stops, it keeps moving upwards, but the earth is pulling down, so it keeps decelerating until it stops somewhere here and keeps crashing down. All right, so that is the case. Okay, so when does it happen? Exactly after 11 seconds, the engine is off, and the aircraft will keep decelerating and stop somewhere and return back, like throwing an apple. Now, when you throw an apple, like this fancy guy, you give an acceleration, and after some time, it goes down, returns back to your hand. So that is the same case here, and the acceleration is 7 meters per second squared. All right, so the first question is, what is the maximum height above the ground reached by the rocket? So let me show you the solutions. No, where you go? Do you see my screen?
Yes.
Yeah, we can see your screen.
Okay, so good. So this is similar to what we have solved so far. I have given you an example, if you remember, in the problem solutions, and it's exactly almost the same thing. And okay, so what happens for, let's say, I said 11 seconds, right? Good. So it is moving with an acceleration of 11. No, what is it? Was that 7 meters per second squared, right?
Yeah.
It's going upwards for 11 seconds. So what is the distance it makes for 11 seconds? V0, it starts from the ground. It's not moving. It's 0. Plus half AT squared. What is this A? It's accelerating upwards. Okay, so it's 7. 7 times 11, which is time squared divided by 2. And until the engine shuts off, it's like 423.5 meters. At this height, the engine is not working. But the thing is that the engine has some speed when the engine is off. It keeps moving and up and up and up, then slows down and falls down again, right? So we have to find how much time does it take for the rocket to stop? Okay, we already know that the speed is, what is the speed after 11 seconds? It's 7, which is the acceleration, time 11 is 77 meters per second squared. At this speed, it stops, but it is decelerating. It's only Earth pulling downwards. So what is the time it takes to stop? Is V divided by G after 7.7 seconds. G,
May I say something?
yes.
Why is the unit for velocity meter per second square? Shouldn't it be meter per second?
I couldn't hear properly. Would you please repeat?
I'm saying, why is it that the unit for the acceleration is meter per second square instead of meter per second?
You mean this one?
No, below. V equal to 8, yeah.
This
Yeah,
one?
the unit 77 meter per second square. Like, I don't understand why.
Oh, okay, yeah, I understand. So the rocket is accelerating upwards, right? With 7 meters per second squared. How long is it accelerating this way? It's for 11 seconds, because after 11 seconds, the engine is off. There is no acceleration. It's only downwards acceleration, right? So for 11 seconds, the rocket is moving with this acceleration. And you find what is the speed after 11 seconds? So the speed after 11 seconds is acceleration times the time. And
But it shouldn't be.
I think I think he's talking about why it's 77 meters per second squared for velocity and not.
Oh, okay. Yeah, it's a typo.
Why velocity squared?
You're right. It's a typo. It's my bad. I'm very sorry. Okay, you're right. I didn't notice that. It happens with me, those typos, because I write a lot, you know, and I don't have time to go over again to check where my mistake is. So, do you get the answer? Because, you know,
Yeah.
the quality of sound wasn't that right, so I couldn't hear it. I'm very sorry for that. So, so the time for the rocket has a speed after 11 seconds. It goes up and stops somewhere here. What is the time? How long does it take to go to stop, right? So that is the same thing here. What is this G? It's only Earth now pulling downwards, which is 10. I take it 10. It's 9.8, something like that. So the time is V divided by T, 7.7 seconds. It will reach the highest, okay? The maximum distance will be after 7.7 seconds. So the distance traveled during acceleration is, don't forget, V0T, okay? During the acceleration now, when the engine is off, 0T minus GT squared divided by 2, you know everything here, right? Because this is 7.7, 7.7, and this should be 296 meters. What is the total distance? D1 is the distance until engine is stops working, plus D2 is the time that engine stops working until the rocket itself reaches the highest distance. You sum them together, you get 726 meters. Right? It's a bit complicated, but if you like think carefully and read it carefully, you will understand what I really mean. And the other question is, let me see what is the other question. So part B, after the engine is shut off, how much time it takes for the rocket to crash into the ground? So what I mean, this is the distance we found, the total distance from the highest maximum, right? And how much time does it take to fall into the ground? You find the time, and you know already this guy, and you find G is like this, and it takes 12.16 seconds. But don't forget that this T is time from the highest distance to the ground. But what was how much time did it take from the engine power off to the highest distance? It should be 7.7 seconds. You sum those guys together and you get something like 20 seconds. Okay, what is the next question? Let me see, which is something like, I disagree with this part C. So suppose you deploy a jetpack strapped on your back 6.4 seconds after leaving the rocket. Okay, so it is something I don't understand here. It says 6.4 seconds after leaving the rocket. But when does it leave the rocket? When does the man leave the rocket? That is my question I have. Okay, 6.4 seconds after leaving the rocket, but when? And since we don't know.
The main explanation, it was saying you're stepping off the rocket in the main part of the question.
Yeah.
Assume that the rocket is in free fall after its engine is.
I got it, what you mean.
So confuse me. Why does the diagram start from the bottom and go upwards and not start from the top and then go downwards? Like the first photo at the bottom is is related to the first question, but then the last question is related to the first photo at the top. That's what I think. That's what had me confused about the question and the diagram.
Would you please ask a bit like more specifically?
I said what confused me a lot in the exam was how, you know, there's a diagram with 3 photos,
Yeah.
and like usually you'd have a diagram like the first one would be at the top and then the second one and the third one. But the first scenario in the diagram, which is the first question, is at the bottom of the diagram.
Yeah, you're right. That made
So I read the beginning is the rocket goes up, and then I look at the photo. He gets off the jetpack, and then it's like he steps off, and then the last one is the rocket taking off. But the first photo I see is him in the jetpack, which confused me a little bit. But it's nothing major.
well, you got the wrong result, right? For the part one.
Yes. Yep.
But did you convince yourself that this is the answer? Did you understand the explanation?
Oh yeah. The thing, my mistake was I completely forgot that he has a new initial speed when he stops accelerating. I only
That's
I only
where you got confused. You got scrambled.
yeah. Yep.
That's okay. It happens to me sometimes. You know, you don't have to like stress yourself. Look, there are hundreds and hundreds other exams coming up into your life, so there are many chances for you to improve. Don't worry. You also need to take GRE exams, which are kind of like this. It's so funny. You should study hard for that if you want to like come to US or Canada. So you need that exams. Okay, so now I got the point. This is the solution. I copied from somewhere else. Right? This is not my solution, and I will solve it myself later and we post it to the blackboard because I don't want to explain something to you that I don't understand. What I didn't understand in this question was this part, and I was asking myself when, and the answer, the question should be like this. Suppose you deploy a jet packet on your back 6.4 seconds after rockets and leaving rocket, and like after rockets engines turns off, right? So that's the way I understand. I was asking myself when, okay, 6.747 seconds, when do you leave the rocket? So that's why I got confused, and I will post that solution later. So let's swap to another question. So where is it? Hold on a second. Is that problem? Not the problem 3. Let me see what the problem 3 is. Is everybody clear so far? Hopefully. Okay, so this is a horizontal surface. It's like a projectile motion. You have a ball, throwing it with making an angle like 52 degrees, and this wall has a height of 5.8 meters. You are 2 meters long, and was asking, what is the question? Let me see. What minimum initial speed must the ball have as it leaves your hand to go over the wall? So there is an initial speed. What is the minimum? If you have higher speed, we'll go like this. Maybe they'll crash the wall, hit the wall. If it's slower, we'll go like this, then return back. So what should be the minimum speed to have this scenario here? So look at what I did. Okay, so this is the guy. It's 2 meters long. We have h, the heightness of the wall, 5.8 meters. There is an angle here, 52 degrees, and there is an initial speed v, okay? And the guy is 12 meters away from the wall. And the question A is, what is this d? Okay, you throw the ball, the minimum speed, and it returns back here. What is this d? So don't forget something. You should never forget. You shouldn't get confused. The ball starts from here, not from the ground. So you should take this difference, 5.8 minus 2. So you need only this guy here. This will matter. Okay, it's like shifting the ground here. Be careful. This is a tricky question. So what is the difference? 5.8 minus 2 is 3.8 meters. Now, so from what is the height So when the body comes here, they should have the position would be 5.8 meters. So I call this H, okay, capital H, this guy here. This should be nothing but the height of the guy, okay, plus V sine alpha t, which is the y component of V, okay, minus, since it is going upwards, it is decelerating, okay, minus 1 gt squared. And on the other hand, we know that, what do we know? That this distance, okay, to go here, this distance is nothing but the x component of the v, which is v cosine alpha times t. I need this expression because I can't find t, right? You can express d or t. It depends on what you want to find. So in this case, I write d, where is it? V. Okay, so what I did, you multiply by the cosine and divide by cosine, right? Cosine and cosine, those guys cancel, and you see no difference with this, right? Plus minus 1g, and instead of t, I write this expression. But v cosine alpha times t is nothing but d itself. So you get this expression, fancy expression, right? So I did nothing but multiply by cosine and divide by cosine. Those cancel, and it's nothing but the same. But here now, d itself, I'm sorry, t is found from here, d divided by v cosine, and you square this guy, and you get this expression. And after some mathematical massaging here, you'll get the v squared is this, is nothing but mathematics algebra. And v itself is d divided by cosine and this expression, right? So we got d is 12, cosine 52, tan 2, h is 2 meters long, 12 tangent, 12 is 12 meters from the wall. Substitute for every value and you get 12.7 meters per second squared. Does it make sense? It is very easy. Like, okay, I'm not going to explain this part. It's like high school mathematics, you know. Just I did nothing but I was trying to find a relationship between this and this. Instead of t, you plug this guy here. And this v cosine alpha t is nothing but d itself. Okay, so I just tried to find the v squared. What the v squared? What is this v squared? V squared is nothing but the initial velocity, and it's 12.7 meters per second squared. So what is the second question? B. For the initial velocity calculated in the previous part, what horizontal distance beyond the wall with the ball land on the ground? So, as I said, what is this d? Okay, we found v initial, the minimum v initial. Now the question is, what is d, right? Here's how I found it. We know that the total distance, d and capital D, right? So this total distance, 12 plus d, what should it be? It's the same like v, the x component of the initial velocity times t, t1, let's say, not to get confused with the previous t, right? It's the total time. On the other hand, we know that when it falls on the ground, the y distance, like the position and y position should be 0. It's not above the ground, right? So it touches the ground, it's 0 meters. It's nothing but, you start from the age, the heightness of the guy who is throwing the ball. This is the y component of the v we just found, minus gt squared, because gt squared, it is always decelerating, it's going in the same direction, minus g, okay? So we plug all this guy here, and from here you get this expression, and I found the discriminant, and you solve for time, okay? I found the time, which is this. It's easy, you plug it in here. So from this equation, I find the t1 by the discriminant, and I substitute this t1 here, d plus blah, 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 and so this is the same thing I did here. But this is a long expression, which I don't like, but what I did is plug in numbers, 12.7 cosine 52, and whatever you do is like 5.38 meters. I think that is clear. You understand what I mean?
I have a question.
Yes.
May you go up?
Yep, scrolling up.
I didn't understand why we said h plus v sine theta blah blah, that equation is equal to 0.
Okay, so start from here. If you remember, this guy is moving with an x. Hopefully I can use, okay, I can write over it. Just hold on a second. So this guy starts from here, which the height is 2 meters, right? So let me share something with you so you can better understand what I mean. 1 second. Is that whiteboard? Okay. So the ball, here's the ball. It's moving with acceleration. If you remember, the acceleration, it is constant, right? Let's say it is g. Right? I'm sorry, don't. Let me delete this part here. Okay. So what is this? Shouldn't be the second time derivative of x position. Let's say y. Okay, equals g. What is the y component of velocity? It is nothing but, should be minus g. Why it is minus g? Because it is downwards. Okay, the body is moving upwards, but g is minus. Right, so this is y, time derivative of y, which is y component of the initial speed v, we should be minus g d. Hopefully you understand, plus should have an initial velocity, let's say v0y. Okay, so what is y itself is nothing but minus g d squared, okay, divided by 2 plus v0y times d. What is this v0y? Is the, you know, the ball is thrown with initial velocity v, and you find the vertical component. Okay, this is v0y. So this is constant, right? So, and this is the x component, v0x, and this is the v0. So what I find here is gt squared divided by 2 plus v0yt plus, what is the y, initial y? It starts from the height of the boy, h. Okay, so this equation, solutions of the equations tell you where the ball is at any instant of time. So this y, if you plug any time, you find where the ball it is. So this is the ground, and this is the 2 meters distance. 2 meters, starts from 2 meters.
Okay, I get it now. I thank you so much.
What is this solution? You don't have to memorize, just solve this equation, like differential equations to the second order, homogeneous. And what you find here is, it's not homogeneous, I'm sorry. So y, it's, okay, you find a solution and you plug time. This time tells you where the ball is, somewhere in the y component of ball at any instant time. When the ball is here, what is this y? 0. Minus g t squared divided by 2 plus v0y t plus h. Hope that makes sense.
Yes, thank you.
You're welcome. So next, so that is what I did here. This is the equation. Okay, the same thing, just y is 0, and this is d plus the capital D, and like you find t here. I found t by discriminant. Substitute t for here, and you find the distance d. Okay, what is this capital D? Is this distance here? That's it. All right, so that's another point. Now, do you see the screen again? Let's
Yes.
problem 4, which is a bit of complications. The problem 4, there you go. We have a pendulum. Okay, so we have a pendulum, and the length of the string is 80 centimeters, and the mass of the ball is ½ kilogram, roughly 1 pound, and there is an acceleration, net acceleration this way, okay, which makes it an angle 45 degrees. Okay, and this A net is 5.5 meters per second square. And the question is, question is, what is the speed of the ball here? One. The second, what is the tension on the string? Okay, so you have to find what is this tension here and what is the speed. This is the Newton's second law. If you remember, I have already talked about the, if you remember, the centripetal force in planets, v squared divided by r, right? So that's the equation we have to use here. There we go. So in this case, this A net, which forms an alpha, which is 45 degrees, you can decompose this with A tangential and A radial, right? This is A radial is the centripetal acceleration, v squared divided by r. This is I use for the planets 1c, if you remember. So it is easily found that A radian is nothing but this times the cosine alpha. Okay, so A radial, centripetal force. What is, sorry, centripetal acceleration? It is nothing but this net acceleration times cosine this alpha. And there you go. We know this, we know the A net, and you substitute here. We already know that the centripetal acceleration is v squared divided by r. We can find this, we find this, and you substitute and you find this expression here. Right, this is part A. It's very easy. This, I think this was the second easiest example. Next, look carefully. There's a tension pulling the wall, right? Centripetally in the center, right? Onto the ceiling. So there's an mg force. You decompose this force in this direction, right? Which is mg cosine theta, right? So the next question is, look at here carefully. There are two accelerations. We have one centripetal, right? What is the centripetal x force? mr radial or centripetal equals t, right? T, this one, minus, what did they say? mg cosine theta, right? That's easy. So eventually you can find that t is nothing but m radial times r, but I'm saying m times a radial, centripetal acceleration, plus mg cosine theta. And that's easy. You already know this one. You know this one. You know m, you know g, you know, and also you know theta. How do I know the theta? Anybody who can help me with that? Look. So this is easily understood actually, because what is this angle here? Anybody who can help us?
45.
Yes. Why? Look
Like
at
when we
this is
put
also,
some,
yep.
sorry, you go.
No, yeah, go for it. You're right.
I couldn't explain, but when we divide it, like it's
Okay.
completely 90. So
So do you see my screen, by the way? So you can see what I mean?
yes,
So this is 45, okay? This is also 45, right?
Yes.
Because this is all 90 degrees. So this is 40, is that 45 given? Yeah, 45 is 90. So there's another here in this direction. So what I mean now, this guy, look, can I draw it here so you can see what I mean? It's more geometrical thing. Look. Oh my God, I have to clean all of this. Okay, so this will be enough. So there is the ball, there is a T, there is also 45 here, right? So if you're now, what I wanted to say, let me see the, 1 second. So basically, don't look at this now, it's not correct, but you will see that this angle is equal to this angle. This is already 90 degrees. Okay, 90 degrees is this guy. What are these if those are the same? 45 and 45. Right, so let me share you the screen. I couldn't draw it correctly, but look at here. So if this is 45, This is also 45 because those are 90 degrees, right? If you plug something perpendicular, right? So you'll see that this angle, NG, this angle is equal to this guy. For these to be equal, this should be 45, 45, and this should be 90 degrees. That make 180 degrees. Does it make sense?
I just
No, I don't agree.
you go.
No, it's right. But you know this, because this is one. There was one here, 90 degrees. But this, what was this angle, by the way? This is what we have to find. So this is alpha, this is 90 degrees, and we need to find this angle here. This angle, look, this angle, if you use geometry, this is theta, right? This angle should be equal to this. But how do I show it now? Let me, 1 second, make you clear something. Hold on. Okay, so there's a ceiling, right? So there is, this is theta, right? So we have a ball here, and hopefully this is the case. So what I mean is, find this angle. Which one? This is perpendicular, this angle. This is theta. Why this is theta? Because this is perpendicular to this, and this is perpendicular to this. There is a theorem, perpendicularity theorem. So it happens that this guy happens to be with this one. It's a theorem in mathematics. If you notice, this is perpendicular to this, and this guy is perpendicular to this. Therefore, this angle should be equal to this, right? So where you go? Do you see the screen now? I just tried to share it. Good. But that is not the solution of there. But now the thing is that what is the, how do I say that? What is this theta? Okay, who said 45?
I said, but according to questions drawing, it's like impossible.
Right, okay, hold on now. Did you understand why this is theta equal to this?
Yes.
Okay, what is this? 45, right?
Yes,
What
but
is
in the
this?
question, it's not like drawn.
It's not horizontal, Aynet.
Yes, I would also like emphasize this point. In the question, A was very like
Where is the question?
inclined.
That is the
Here.
thing that confused all of us, I think.
This angle.
Yes.
Okay, don't worry about this. Okay, this is 45 and this is another 45. You get something like the tangential component here. Don't look at, just look at this part here. Just trying to convince you something to say that, okay, do you see that? Don't look at the direction of this, okay? That can be a little bit upwards tilted, or a little bit downwards, doesn't matter, right?
Aslında öyle olunca da gerçekten çok confuse oldum. Çünkü yani
You're
her
right,
iki halde de 45 olamaz.
but I don't understand.
Yukarı doğru olunca ister istemez bir şey değişiyor.
I don't understand Turkish.
Okay, I mean,
I understand. Okay,
in
so,
the continue.
yeah, I mean, this A can be tilted in any way, right? It doesn't matter. It can be here. It's just like the representation. What I'm trying to say, I convinced the student that this theta here should be equal to this. In mathematics, there is a theorem called perpendicularity theorem. And I showed you that why this equals to this. But now there's a triangle here. Look at here carefully. There's a triangle.
Yes, according to your picture, the theta is equal to 90 minus alpha. But in the question, it doesn't look like theta is equal.
You know, it's a three-dimensional representations in here. So you're right. You don't have to. You can't measure the angles. Where is the question? Here, you cannot measure the angles, right? Just looking in a three-dimensional representation of the case. So it depends on what it says. Actually, this is, to be honest, this is 45 degrees. I don't think so. It should be a little bit here. So there's a right angle formed here. This is not exactly 45 degrees. If you have something to measure, you can see that is not 40, it's like 35 degrees or something. You have to move a little bit here until this becomes perpendicular, right?
How do we know it is perpendicular?
Okay, that is also another good question. You know how I know it? Let's go to the representation. This is 45, right? If you take the tangential, so which is, this is 45, this angle has to be 45, right? Do you agree with that?
Yes.
Yes.
Yeah, but you're asking how do we know? This is more in a geometrical way. 1 second. Let me go to my representation, because I didn't check the representation of the answer, the question, you know, because it's so confusing. So what I did, right? Look at here. So you drop a perpendicular guy. It's okay. It can be roughly, right? Because this is a geometrical point. If you are a mathematician, you wouldn't accept me saying it roughly just by drawing the forms. It's not accepted in this way. But roughly, if this is 45, this is roughly 90 degrees. Okay, they are just doing calculations roughly in this sense, right?
Okay, but I also have one question about this part B. I wrote it like I separated the tension force to its components.
This way,
T
right?
cosine. Like a little bit different than I wrote that M multiple A net is equal to T sinus theta. Did you get what I mean?
Yes.
And while calculating from this, the answer was wrong. Can you explain, please, why it is wrong?
What angle did you use? 45 degrees?
The sine 45 degrees is 1 over square root 2. I wrote in this way, but it was wrong in me.
Did you check the calculator? Maybe it's something, because that shouldn't be the case, you know. Okay, you see this cosine theta, you express it in a sine theta, but in that sense, I should check it. Did you check it with Professor Nazmi? Because I didn't check your exams, to be honest. I have no access to that part.
No, I haven't told Nazmi yet, but I will say it.
So I'm taking this theta. Okay, you are asking, that's a good question. You take this theta 45 roughly, you get a rough example, right? Because it's not right perpendicular. It's not right 45 degrees. You have to find theta in these expressions. You see, it's not 45 here, right? But you'll notice that theta is almost 45. For your simplicity, like in your calculations, I'm saying that you can take theta roughly as 45 degrees, but that will not give you 100% solution, all right? So where are we right now? Let me see. Is that a little bit clear or still ambiguous?
Yes, it is clear. It's also true way for solving, but can you please a little bit scroll up?
Sure.
Oh, in the top picture, you separated the mg into two components, mg sine theta and mg cosine theta. But instead of this, I separated the tension force into T sinus theta and T cosine theta. T cosine theta is like upward.
What do you mean by, you mean this guy here, the tension?
T tension, yes.
Okay.
I separated it to and T sine theta and T cosine theta.
Separated it with respect to what?
Just like with due to this triangle, theta alpha, I separated it to the like t sine alpha and t cosine alpha.
This is along the radial part. So how do you separate this with respect to what axis? And you can do that, but what is the point of doing that? You will not end up anywhere.
I thought that the centripetal force will be equal to t sine alpha.
This one, mg cosine alpha will be equal to this guy. But for the other, I don't think that makes sense if you do that. Okay, you can do that. You can split the force up and onto any axis, but you will not end up anywhere. It's not something new. Just looking at the force from different directions. But you're not going to calculate anything like, you're going to see the same vector from different points of view. But you will not get an interesting result in it.
It's not in equilibrium. Because of that, it's not true, I guess.
Yeah, it should be in equilibrium. So to be in equilibrium, it's not in equilibrium first, because to be in equilibrium, there should be like 2 points to be satisfied. The torque, net torque should be 0, the net force should be 0. So net torque here is not 0. Why it's not 0? It is rotating, it has angular momentum, and so on, changing with time. So torque is non-zero. So it's not about equilibrium here. But what you mean by equilibrium, probably you mean this equation here, right? Am I correct, Sarah?
I said it because of the question, like he did.
Yeah, that can. All right, so what else? What else we got here? Good. So somebody else, okay, I told you that this theta can be taken as roughly 45 degrees. We had other students saying why this is perpendicular. You are correct, you are right, roughly it's perpendicular, but to be more precisely true in a mathematical sense, right? Don't forget something. Okay, look at this equation here. You find t equals ma radial plus mg cosine theta, okay? But don't forget that this radial, right, m radial, that is equal to ma tangent. Right? Why is it ma tangent? It is because it is 45 degrees, and this a tangent equals to a radial, right? Does it make sense? So if this is ma tangent, now you see that you can find that this one, which is radial, is nothing but g cosine theta, right? And you find you find the cosine, you find this relation. On the other hand, a tangent, this one, right, equals to what? This one, g times sine theta, right? And you can find the sine theta here. So what I did here is just you express the tension with respect to like net acceleration, and that's it, right? So you get this expression. You can convince yourself that this is true, whereas a representation of that. So let me see now question 5, so I don't take much of your time. This is a bit crazy question. I think this was a little bit complicated. It took a few hours to. Okay, when I do the exam, I do it quickly, but in order to explain, I have to draw the diagrams, be careful. It takes like 1 hour to solve it. Because I'm solving it to explain, not to get the scores. Let me do, so for the screen, you're okay, right? Where is it now? We should go to question 5. Is anybody who got 100 in exam? Who aced this exam? Or no one? Okay, so here is like an incline, and we have an MA, an object here, an object of mass MB. The inclined mass is M and forms an angle theta. So there is friction here, and this system is left to move with constant acceleration this way, right, downwards. B goes up, downwards, M goes upwards. Hopefully you don't have any class right now, but so they can go a little bit quickly, and you will not miss the class. 1 second. How do I find it? Where is it? Yes. So this is the case. First of all, you draw the body diagrams, right? You take MA. MA is nothing but there's a force in this direction, right? There's a friction force here, and there is an MGA, right? And tension T. This is the first diagram. The second this is for M. So here there's a force in this from the ground. It has its own mass, right? In this direction. So there is another mg in this direction. There is don't forget Na. You see Na in this direction, but it's pulling this way also. Na and Fka, right? So is the force in this direction. How do I say that? Friction force.
Can I say something here?
Yes, go for it.
I think in the body diagram we draw for the block.
Alright, then let's begin the
The
this one.
block.
Right? So
Yes.
there is a
For the biggest block, the inclined block.
Okay, for the inclined block here, mass.
Yes.
It has an mg.
Yes.
Capital MG, this direction, right?
Yes.
I'm
I'm not. I'm saying something different than that.
Yeah.
I say I think we should include T's because T from right side and left side should be included in the body diagram.
The thing is that these
because
T are
rope.
There is no friction here, so T doesn't count here. Okay, you're plugging this guy upwards or this downwards, but due to there is no friction between this guy and this, this T is not directly affecting this guy here, M. It's affecting the object, right?
But it's affecting the makara. What is makara in English? I don't know.
Pulley?
I don't know the English of something. I don't say.
Yeah, pulley.
Yeah, I know what you mean.
Oh, pulley, yes. I mean, pulley, the rope is affecting the pulley, so we should include T's. T cosine theta.
You should include that. If you consider friction here and though, but it says in the question, where is it? Oh, I don't find the question right away. I think yes. You see, the pulley, as far as it says, it's massless. When it says it's massless, you don't have to consider those differences in T, which will be, if it's T bigger than this, maybe the object will move in this direction or something. You don't have to, because it is massless. You don't consider pulley.
Yes, I'm not considering it, but the pulley is just stick with the big M inclined block. So when we apply a force to pulley, then the effect of these forces should be affected also the big M inclined.
Wouldn't this tension T affect the friction force, the magnitude of the friction force? If it's a friction force big, and if you're pulling with T, this friction force, the effect on it, the net T minus friction force, wouldn't that affect it as well? Where is my question? There we go. Nope. My solutions. There. So if there's a T pulling this guy upwards, right? Shouldn't there be?
Yes.
Shouldn't there be like a friction force here, affected by the T? Right? So for the second, and if you see those Ks are all affected by those T's, but not by the pulley itself, because it's an ideal pulley, right? So for this diagram, it's not going to help you that much. But anyway, say this Fk, see, is like thinking of there's no friction here actually, right? It is static. So all the forces, net forces should be where it should be 0, right? Why it should be 0? Because this capital M is not moving and there is no friction here. That's the best part of this, which is going to be helpful. And you can express this like NA, which is this like vertical component of the mg, right? So, and Fk now, this Fk, if you look here, this is affected by this T. What is this Fk? This is Fk is T, capital T you were talking, minus the friction force. All right, so that is what I meant here. So basically, so you're right, T should be included, but what I'm saying is friction force is like there's a net force between those T and friction force. So these are affected in somehow and it's just denoted by FKA. So you just take this guy for the first block, MA, and this expression for the this incline. And for B, this is the easiest thing you can ever say. In X direction for this, there should be a force here and a force here. There should balance here, and wall and wall body. Right? Those are equivalent. At the same time, there is a friction force, right? Friction force because there is a friction here, and this is pulling in this way. There should be a friction along this part. Since is it moving downwards? The friction force will be here. Because there
should be no friction here.
Sorry?
Because there is no normal force and friction depends on it. So there is no friction for block B.
There should be somehow, because you know why? Because MA is pushing this body in this direction. And this MA pushing this M, capital M, the force on B that pushes along the wall. You see what I mean?
But like shouldn't the normal force be if the block is pushing against the if block B is pushing against the wall, there will be some normal force, right? But it's not pushing against it because it's going downwards.
Of course, but you know this M, MA is pushing this, and this eventually pushes this. You know what I mean? So MA is pushing capital M, this incline, by some force in this direction, and therefore is going to push B somehow and giving some this force. So this N wall and B is related to the mass of this. If this did not exist, then there would be no force here, no friction force.
I see what you mean now.
But since this is up here, what happens is there is a force, and this is being pushed rightwards. And there is a how do I say that? Net force in the X component because of this.
Thank you.
You know what I mean? So you construct this body here, and you can see that using this 1, 2, 3, I noted here, 1 is 1, 2, 3. Here, 1, 2, 3, and you can find that the tension is this. It's just a mathematical manipulation, right? Tension, like the same like this one. And you can use equation 6 to find that M wall minus N wall, there's equation 6. It should be 0 because the net force is 0. The system is not moving anywhere, just in this direction, in this direction, but the whole system is not moving. Therefore, there is no net movement in this direction of this MB. Right? So, therefore, this should be 0. This is the answer of the part B, I guess. Right? Net force, this should be 0. This is for part A and part C. This is easy. You can use number 4 here. Okay, why you need number 4? You can find this NB. NB is nothing but this, the sum of those two. All right, and the equation 6, 8, 9 here I have denoted. So and this guy here, you can use them to find this expression. This is what you need here. And you can use eventually using 6. Why using 6? You can find the mass. Why is the mass, 7 to find this MB? Because you found this, you found the tension. You can find the mass in respect to those. Right?
Now I know what I messed up, because I thought that in the exam, because there's the net normal force is 0, I thought that there's no friction, but friction does not depend on net normal force. It depends on the normal force between the two surfaces only.
Of course, that's the case. Only this surface. Don't confuse with this. Only this surface here.
Mm-hmm.
There is no friction force here.
That's where I went wrong.
Okay. That made you. Did you get it wrong in your questions?
Yes.
That is so sad. And there are other ways you can improve. I will upload this into the system. Okay, the exam was a bit hard. I think the last question was not that easy. I don't know how many minutes you had for this.
We have for the whole question 20 minutes.
Because you have to think over and over again. And some students got the right ones, some of them got the right one. But if you don't know how to manipulate those equations to get these, you still get 0, which I don't think it is fair for a student who knows the free body diagram and who knows how to write these in equilibrium basis, and still you get 0, which I don't think that is fair for evaluating students. But if you have any concerns, then feel free to ask me, and I'll see you in a few minutes in your problem solution set. Right?
Thank you very much.
You are welcome. Take care. See you later.